Moving on to problem 3. This one is asking for the output current of this operational amplifier. So let's go and think about this real quick. We know that this current is going to be the same as this current through the 33 kilo ohm resistor because there's no current entering or exiting your op amp. So that means that the current through this resistor equals the current through this resistor equals the current through this resistor. So your next step is just to find what that current equals. We know that at a junction, the sum of current in equals the sum of current out. Or in other words, this current minus this current will give you this current, which is the same as your output current, as we just established. So to find the current through the first 10 kilo ohm resistor, you just need to do a transformation on your voltage source into a current source, which is pretty easy. Doing so gives you a current of 0.0025 angle 0. Next up, we need to find the current from this capacitor. The current of any capacitor is equal to the capacitance times the derivative of voltage. So you take the derivative of your voltage equation, which gives you negative 1.25 times 10 to the 6th sine 50,000 t. Now you multiply that by your capacitance, which is 200 times 10 to the 9th. And if you simplify that, you get negative 0.25 cosine 50,000 t minus 90 degrees. That's your phase angle, because remember, after you derive it, you're in sine. So to convert back over to cosine, you just use a phase angle of negative 90 degrees. Moving forward, we now know the current from the source and the current from the capacitor, so we can find the output current. Doing so gives you 0.25 cosine 50,000 t minus 89.4 degrees, which is very close to the current from the capacitor.